So in this video I'm going to talk about how to solve linear equations. We're going to talk briefly about the balanced scale model, but then we're going to not focus on this model. We're going to just do it the quote-unquote normal way. One of the homework questions asks you to solve these problems, these types of linear equations using a balanced scale model, but I don't believe you have to show the work or anything, so whether or not you use the balanced scale model, I'm not really concerned about, but you can if you want to. Okay, what this scale is representing, this is a scale and it's balanced. That means these two sides have the same weight. Okay, so what this particular diagram here represents is the linear equation x minus 4 equals 6. Okay, so that's because on this side of the scale we have x, and then we have these blocks which are each -1. Okay, so there's 4 of them, so that's the -4 part. So you have, over on this side of the scale you have x, then -4. Over here you just have 6 blocks that have +1, so that's 6. The fact that they're balanced means that they're equal. That's where the equal sign comes in. Okay? Well, we want to know, usually in all these algebra type problems, what we want to know is what is x. Well, if we add 4 positive blocks over here, what's going to happen? Well, what would happen is, since the scale was already balanced before we added those 4, now the scale would tip this way. It would be heavier on this side. Okay? We don't want that. We want it still to be equal. So we have to add 4 over here. I can't draw. So, since we added 4 over there, 4 positive blocks over here, to have the scale still be balanced, we had to add 4 positive blocks over here. The reason why we picked 4 positive blocks and not 10 or 150 or 2,000 is because there were 4 negative blocks. So we wanted to get rid of the negatives by adding a positive. So each of these cancels out, and we're left with just x. Well, over here we're left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means to show the work the normal way without drawing a picture, we added 4 to each side, and we wind up with x equaling 10. Okay, so even with the picture, you still really just use normal algebra. That's why I'm not going to be concerned about it. The homework questions tell you to use that model, but I don't think you have to show the work anyway. If you do, you just saw me demonstrate one example, which all the examples would basically be like that anyway. Let's just do one or two the quote-unquote normal way, where we don't draw a picture, because for me it's hard to draw a picture. Alright, so sometimes there's more than one thing you have to do in a problem. If you notice the last problem, it was just x minus 4 equals 6. All we had to do is add 4 to each side. The reason why we added 4 is because the x was having 4 being subtracted from it. So we wanted to do the inverse operation of subtraction, which is addition. So to undo that -4, we had to add 4. And then whatever you do to one side, you have to do to the other. Well, here, once again, we're going to try to get x by itself. So I see that before I say what I was going to say, when you're trying to get x by itself, just x alone by itself, you want your end product to be x equals something. The first thing you want to do is to get the term with the x in it by itself. So this has two terms in it. There's the 2x is a term and 3 is a term. Okay, so we want to get 2x by itself. Well, since 3 is being added to 2x, we want to subtract 3. We want to do the inverse of addition. So we subtract 3. But remember, you have to do it to both sides. Okay, so we wind up getting 2x equals 7. So now x is being multiplied by 2. To undo that, we want to do the inverse of multiplication, which is division. So we want to divide both sides by 2. So in this problem, x is 7 over 2. Okay, that's a perfectly fine way to leave your answer. If you want to know what the decimal is, you can do 7 divided by 2 on your calculator. But it's a perfectly fine answer. I prefer answers left as fractions. Alright, let's do at least one more problem. Really, we only have to do one more problem. Let's see if there's a type of problem that looks harder than others. I don't think there are. I think we pretty much handled it. Let's see. How about 3x plus 8 equals 17? So, once again, let's try to get the term with the x in it by itself. Okay. So since 8 is being added to 3x, I want to subtract 8 from both sides to get 3x equals 9. So this means, remember, when you write it 3x, it means 3 times x. So the x is being multiplied by 3. We want to undo that because we want x by itself. So the inverse operation to multiplication is division. So we have to divide by 3. X equals 3. Alright, so nothing too groundbreaking or difficult. Should be relatively easy. And in the next video, I'll talk about linear inequalities.